Okay, today while I'm gone, we're going to review the rules of exponents that we've talked about, that we worked on, that we just took a test on. We saw that this was one of the tougher things that we did in Unit 6, and it's something that you definitely want to continue to work on. You will see problems like this in the future on my quizzes and tests, and you'll even see harder problems next year in algebra class. So definitely want to be paying attention and taking notes as we review these properties of exponents before I give you your assignment for the day. Just want to quickly go over the 5 different properties that we talked about in Unit 6. They should be on your Unit Essentials map. Should already taken notes, but just wanted to review. The first situation we have there where we have like bases being multiplied, we said that the base would stay the same, so we'd still have a, and then we would add the exponents. So we're looking for patterns where we see problems like that. That's our rule. Base stays the same, add the exponents when we're multiplying. When we're dividing, it would be the opposite, so the base would stay the same and we would subtract our exponents. But again, you got to have like bases and got to have division, then you would subtract the exponents and the exponents would stay the same. The next rule that you see there is our power of a power property. What we said, if I'm taking a power to another power, we would leave the base the same and we would multiply our exponents now. If you don't understand that idea, let me give you a quick example like we talked about in notes. If I have x squared to the third power, that means I have x squared times x squared times x squared. Obviously, we'd add 2 plus 2 plus 2, which is 6, but again, a shortcut for 2 plus 2 plus 2 is just to say 2 times 3, which would give us x to the 6th. So a good example right there. The next 2 properties kind of go hand in hand as far as what we're looking at, the power of a product or the power of a quotient property. Basically, what you need to understand, if I have something in parentheses taken to a power, everything in the parentheses is going to be taken to that power, whether we're multiplying or whether we're dividing. Every single term or every single factor in those parentheses are going to be taken to that power. Make sure you have these down in your notes. You already should. You should also already have these on your essential map, but they will help you with the problems we're going to do in notes as well as the assignment. First one, we have 5 to the 3a times 5 to the a plus 2. What I want you to recognize, you've seen problems like this on your test and everything else. This is really the problem we have here. We have a like base that we're multiplying. That tells us that our base is going to stay the same, so we have a base of 5, and then we're going to add our exponents, 3a and a plus 2. So I would add 3a plus a plus 2. Your algebra background knowledge should tell you we can't combine all these things, but we can combine like terms. So I have a 3a plus a, which would be 4a, and then I would still have the plus 2. So my final answer should be the base stays the same, 5, to the power of what my exponents were when I added them, 4a plus 2. There are problems like this on your assignment as well, so definitely want to make sure that you have that example down. Next one I'll let you get copied down, 15x to the 6th y to the 3rd over 10x to the 3rd y to the 3rd. So you see a division situation, you see some coefficients, you see some like bases. When we talked about this, the first thing we wanted to do is just try to simplify our coefficients, reduce our coefficients, do what we can there. If I have 15 over 10, I can divide those both by 5, and I should know that I'm going to end up with 3 over 2. So I'm going to have something as far as 3 over 2. Then we see that we have x to the 6th over x to the 3rd, and we have y to the 3rd over y to the 3rd. This reminds me of our rule. If we have like bases in division, we're going to subtract. So x to the 6th over x to the 3rd, 6 minus 3 gives us x to the 3rd, and that would be on top since there's more x's on top. And then notice we have y to the 3rd over y to the 3rd. If we expand that out, we have y times y times y over y times y times y. All of that cancels out, because 3 minus 3 is 0. Anything to the power of 0 is 1. And so all we're really left with as far as this is our variables. We're going to put that back together with our fraction. Our final answer should be 3x to the 3rd over 2. And again, you will see problems like this on your assignment and on quizzes and tests in the future. Next example, 3x squared y cubed to the 4th. A couple rules that are going to help you on this one. We talked about this situation. We're going to take each thing to that power. And then we also talked about the situation where you have a power to a power, and we're going to have to multiply. So both of those rules are going to apply there to us when we're working on this problem. 3x squared y cubed to the 4th. This means I'm going to take everything to the power of 4. That's 3 to the power of 4, x squared to the power of 4, and y cubed to the power of 4. Now we just need to simplify that. I need to think of what each of these are. 3 to the 4th means 3 times 3 times 3 times 3. That actually gives me 81. And now, like we saw, when we have a power to a power, we're going to multiply our exponents. 81 x to the 8th, and 3 times 4 is 12, so this would be y to the 12th. Similar looking situation where we have division. Same rules still apply. If I have 2a cubed b over 3c to the 4th, and that's all taken to the 3rd power. Our main rule, and we're going to use some other ones too, but this is the main rule I'm checking you on. If I have a divided by b to the m, this will be a to the m over b to the m. I've got to take everything to that power. So watch very carefully as I show my work, taking each single term in the parentheses to that power and leaving it in that fraction. So on the top I should have 2 to the 3rd a to the third, and then I should have b to the third. That would be all over 3 to the third times c to the fourth to the third. So check and notice how I've distributed essentially that power to each term in the parentheses. Now I just got to clean it up at each term individually. So I have 2 to the third, which is 2 times 2 times 2, which is 8. And then again, when I have a power to a power, I will multiply those exponents. That should be a to the ninth. And then notice I just have b to the third, so that would be b to the third over the top of 3 to the third, which is 3 times 3 times 3 gives me 27. And then I'd have c to the 12th when I multiply my exponents. And that's my final answer. So four quick examples, along with just a quick review of the properties. This should help you get ready for today's assignment, for homework coming down the road, and hopefully to just do better on quizzes and tests and in algebra class in the future.